So inverse matrices. We have something called an identity matrix. Okay, so just like with the determinants that we talked about yesterday, we are going to talk about identities and inverses, and then we'll talk about why we care and how we're going to use all of this stuff. Of course, your ISN page doesn't mean anything to you. But all right, so our identity matrix, and you denote this with a capital I and a little sub n there. It is a square matrix. So an identity matrix is always square. And remember, when you multiply, they don't have to have the same dimensions, but the identity matrix does have to be square, okay? That when multiplied by another matrix equals the same matrix. So if you have, so like 1 is your identity number. So 5 times 1 is 5. So if I have some matrix times the identity, I'll get the same matrix back out. Okay, 1 has a lot of purposes, so your identity matrix does as well. So if A is an n times n matrix and I is an n times n identity matrix, then A times I sub n, okay, I take my matrix A, multiply it by the identity matrix, this is equal to A. And I sub n times A equals A. Remember the other day we did A times B and B times A and they were not the same thing? With the identity matrix, it is. Okay? All right, so an identity matrix looks like this. It contains 1s along the main diagonal and 0s for the remaining elements. So your 2 by 2, an identity matrix that is a 2 by 2, looks like this. We have 1s along the main diagonal and then 0s for everything else. Oh, gosh, I can't scroll. So if I have a 3 by 3, it's going to look like this. 1, 1, 1, 0, 0, 0, like so. Okay. So let's do a little bit of an example that's not on here. Let's do this over here. We're going to do 2, 3, 4, 5. Okay. And we're going to multiply it by the identity matrix, which is 1, 0, 0, 1. So if you recall from a couple of days ago, when we multiply, so this is a 2 by 2 times a 2 by 2, which is going to end up with a 2 by 2. So when I multiply them, I take the first row times the first column, and I add them up, right? So this will give me, I'm going to do 2 times 1, which is 2, plus 3 times 0, which is 0, right? We good with that? Then I do 2, 3 times 0, 1. So that's 2 times 0, which is 0, 3 times 1, which is 3. Then I do the second row times the first column. So 4 times 1 is 4, 5 times 0 is 0. Then I take the second row times the second column. 4 times 0 is 0, 5 times 1 is 5. So you see how I ended up with the exact same thing? That's why it's called the identity matrix. It's like multiplying by 1. Okay, we good on that? All right, but it has other purposes besides just multiplying by 1. All right, let me make sure I get all these letters down right here. All right, so if I have 2 n by n matrices, or if they are inverses of each other, okay, if they are inverses of each other, then A times B is equal to I, and B times A is equal to I. So in that case, if I multiply backwards, the only time it's going to be the same is if you actually get the inverse matrix, okay? And then this says if, right? Not all matrices have inverses, okay? Or I'm sorry, yeah, if it has one. It's denoted by A inverse, then A times A inverse is equal to I. And A inverse times A is equal to I. So just like when you did functions, the inverse of, so like if you have f of x, and you have the inverse, it's f inverse of x. It looks like it's to the -1 power. That's not what that means. That just means inverse. Okay. Also think about this. If I have 8 to the -1 power, what is that? What happens when you take something to a negative exponent? Fraction. Okay, so 8. So if I multiply 8 to the -1 power times 8, guess what that equals? It's 1, because that's 1/8 times 8, and that equals 1. Okay, because those are inverses of each other. When you multiply two inverses, you get 1. So what we are trying to determine here is whether the pair of matrices are inverses or not. Okay, this is the first thing we're going to look at. So we are going to multiply these two. I'm going to take my first row times my first column. So -1 times 5 is a -5, plus 2 times 3 is 6. Right? Then first row times the second column is going to be -2 plus 2. Okay, I'm just multiplying. We've done this before, right? Everybody with me? Second row times the first column, 3 times 5 is 15, plus -5 times 3 is -15. And then second row, second column, this is going to be 6 minus 5. Okay? So that when I am done, this gives me 1, 0, 0, 1. That is my identity matrix. When I multiplied those two together, I got the identity matrix, so my answer is yes. Okay. Everybody okay with that? Questions? All right. Let's do 2. We got some fractions in here. Let's not freak out and shut down. All right. I'm going to multiply this times this. Okay. -6. Maybe I shouldn't put my bracket yet. -6 times -5/3. First of all, will that be positive or negative? Positive. Can't I just think about that as 6/1 times 5/3? Yes? So that would give me a positive 30/3. Yes? And I can write it like that for now. I'm just going to leave it for a second. So that's what these, yes, it would. Leave that right there. And then -3 times 3 is a -9. Okay. Then first row, second column. That's going to give me a positive 6 plus, I'm sorry, minus 6. Yeah. Positive 6 and then minus 6, right? Yeah. Then second row, first column. 9 times 5 is 45, so I got a -45/3 plus 15. Then second row, second column, that's a positive, I'm sorry, that's a -9, and then plus 10. All right, so we already said 30 divided by 3 is what? 10. Minus 9 is 1. 6 minus 6 is 0. -45 divided by 3 is what? What's -15? And then plus 15 is 0. Yeah, it's 0. And then this is 1. So my answer here is yes. Okay. Everybody okay with that? All righty, let's do this next one here. I'm going to have this times this. So that's going to give me 48 minus 48, right? 48 minus 48. And then this is going to give me negative 16 minus 15. Okay. So now before we really do anything else, is this looking like the rest? No. This is going to give me 0 and negative 31, right? Is that going to work out for me? Do I need to do anything else? No, I don't have to keep going, just no. Oh, that should be plus 48 anyway. Sorry, I knew there's something was wrong there. And I was like, my sign is correct. It really doesn't matter because it doesn't work out anyway. But negative 48 and then plus 48. I'm supposed to be adding those, not subtracting them. Either way, that'd give you 96 and negative 31. It's not giving you what you want anyway. So that's just a no. Y'all didn't stop me. That's why I was pausing there. All right, and then we don't need to do number 4. Y'all get the idea? Okay. So now let's talk about how to find the inverse. So that's how we know whether or not they are inverses. And like I said before, not all matrices have an inverse. Matrix A does not have an inverse if the determinant of A equals 0. Do we know how to find the determinant? Yes, we do. Okay. So if A equals this, then the inverse is 1 over the determinant. Remember, if it's written like that, that doesn't mean absolute value. That means the determinant of this. And look what happened. These two changed places. These two didn't, but the signs changed. Okay? And it's when the determinant's not equal to 0. If the determinant is equal to 0, we don't have an inverse. Right? So the first thing we have to do is find the determinant. We can do that. We did that yesterday, right? So the determinant, and we'll just call it A, I guess. The determinant of A, this doesn't have a name. Remember, we take the down. So determinant of A, just as a little reminder, that is down minus up. 4 times 3 is 12 minus multiplying these, you get 6. So my answer is 6. Everybody okay with that? All right, so now to find the inverse, I do 1 over the determinant. That's what this is. Then using this first one, my first diagonal, the two numbers switch places. On the up diagonal, we just change the signs. Everybody okay with that? All right, so then I multiply. This is your scalar multiplication. So each number gets multiplied by 1/6. Those are whole numbers. That's a fraction. Think of it over 1. I'm going to write out an extra step that some of you might not need, and that's okay. 3 times 1/6 is 3/6. 1/6 times 1 is 1/6. 1/6 times 6 is 6 over 6. 1/6 times 4 is 4 over 6. And then we just reduce the fractions. 3/6 is what? 1/2. 1/6 is just 1/6. 6 over 6 is 1. 4 over 6 is 2/3. There we go. There's our inverse. What questions do you have? Okay. Might need to go steal some more toilet paper. Also hand sanitizer. Somebody had a weird eye thing yesterday. I was like, okay, use your hand sanitizer and give me some. I don't want to, trying to help her there. All right, so the first thing we're going to do here is find the determinant. the determinant of, we'll call this A. We take the down, that's -8, minus the up, which is a -8, and that gives me 0. What does that tell you? No inverse. So if you get 0, it's easy because there's no inverse. You know what else would be real easy? If your determinant was 1, because that could happen. Then you just have to flip the numbers and no big deal there. Okay, we good? All right, so on this next one, I want you to go ahead, find the determinant. Without me telling you what to do, let's make sure we can all get through this. Okay, do we agree that it's -26? No? Okay. All right, so then the inverse, we're going to take 1 over -26 and then set up what your next, what that should look like based on that pattern. You've got an example up above that's typed out for you, right? Marcus, you got it done? Quit being a slacker and write it down. I can't even read my numbers. It's a -5. All right, we agree with this? Yeah? Okay, then you finish this up, fractions and all. I know, it's terrible. Oh, you bunch of losers. I hear the calculators. It's okay. Try to do it without the calculator. Do it for me. There you go. That's a plus. Well, do it without, and then I'll tell you what to do. How's that? I will tell you how to handle the fractions on the calculator if you don't know, but I want you to try this first. Because yes, I know that you will always have a calculator handy. It's on your phone, the whole 9 yards, but it really does make a difference if you understand the concept without the calculator, just doing simple math, making sure you don't get ripped off at the store, things like that. Why is the 6 negative? Oh, wait, this one, shoot, hang on. This should not be negative because it's the negative. I put it on the 6, but it's really on the fraction. I'm just used to it. It's because this is negative and I missed it on that one. Sorry, that's my bad. If it was typed out for you, it'd probably be out in the front of it. But on a fraction, it doesn't matter if you put it on the numerator and denominator. I think I was just probably trained at an early age and don't realize it to put it in the numerator, but it doesn't matter. Okay, we all good? All right, so if you get out your calculators, I will show you how to reduce a fraction on the calculator. It's very easy. But what I want you to do is in situations like this, I want you to try it without a calculator. Use the calculator to check yourself, right? Calculators aren't evil. Photomath isn't even evil if you're using it for the right thing. I'll be honest with you. I was tutoring last night, and we were trying to factor something, and I was like, girl, I don't think this factors. And we were missing a number, so I said, hang on. So I used Photomath, and I was like, I'm using this, but this is how you use it. Then I figured out what the number was, and we were both just being ridiculous, and then was able to figure it out. So it's not terrible. Okay. So I want you to type in, well, just type in 6 over 26 and hit enter, and it'll give you a decimal, right? Okay, but you're like, dang it, I really wanted the fraction. Now hit math, enter, enter. Bam. Okay, Math enter enter will be your best friend. And if you type in something like 5/26 and you hit math enter enter, it gives you 5/26 back. That just tells you that it's reduced. Now do the square root of 2. Square root of 2 and get the decimal. Then math enter enter. Square root of 2. Hit enter, get the decimal, then math enter enter. And what happened? You got the decimal back, right? Okay, that's because that's an irrational number. You're not going to get a fraction. Okay, so there are times where you won't get a fraction back, and that means it's not rational, so you can't. Okay, but when you're trying to reduce a fraction, you type it in, math enter enter, bam, you're good. Okay, we good on that? Questions? We don't need to do the last one, do we? Y'all get the idea? Okay, perfect.